So the second conic section I want to talk to you about today is the parabola. And parabolas are a little bit more complicated than circles. You can already see that there are two standard form equations, but there's still nothing really to be intimidated by. Now we have a few key features that we're going to cover right now, and I'll show you how to solve some common problems. First things, you have to know which of these is for which type of parabola. A parabola is a generic U shape. Right? It will come down and up, or up and down, or left to right, depending on what kind of equation it is. And if it goes up and down, that means your x is squared. So this is the up and down parabola. If your y is squared, then this would be your horizontal parabola. All right? So you can tell by looking at the graph or the equation what the appropriate counterpart is. All right, so I draw a coordinate plane here, and I'm just going to draw a generic parabola. Those of you who have been doing Algebra 2 will recognize this as the graph of the basic quadratic function. That's what a parabola is. Parabola is the graph of a quadratic function. So you've actually done most of this work already. We're just making it a little bit more formalized towards the end of Algebra 2. And so there are two key features of the parabola you have to be aware of. You're already familiar with the vertex, which is the point where it changes direction. That's your h and k. All right, two new features are the focus and the directrix. All right, and the math behind which one's which and why can get a little bit complicated, and it far exceeds the scope of Algebra 2. So I'm just going to cut right to the chase. All right, the focus is the point around which the point will bend. Your graph is going to go around the focus, through the vertex, around the focus. It won't touch it. It goes around it. All right, your directrix is on the opposite side, and it is an asymptote. You should remember what an asymptote is. Okay, so your parabola will never touch this directrix. It goes away from the directrix and around the focus. Okay, so this is your directrix. Okay. And an important feature is that the distance from the focus to the vertex and the distance from the focus to the directrix is always the same. All right. In standard form, that is considered c. Okay. And that's going to be a common feature in other quadratic formulas and in conic sections, is c is always the distance from a focus to the vertex. Okay. Now we're going to use that quite a bit. But since it's the same, that means we can actually solve for missing pieces and use those to generate equations. For example, if they tell us that our focus is at 0, 0, it's at the origin, and our directrix is y equals 4, we can use those to find our vertex and put this into standard form. Now, a lot of teachers and our Algebra 2 book are going to tell you that you can just do this in your head. All right, it's just a simple set of equations. Let's not do that. Anytime they give you the pair, it doesn't matter which pair it is, always sketch it out. Just like in geometry, sketch it out. Save yourself the trouble. All right, so our focus is at the origin. It's at 0, 0. And our directrix is at y equals 4. 2, 3, 4. So we have a horizontal asymptote here. And our graph is going to go around the focus and away from the directrix, which means it's going to open down. So right away we know we're using our first equation. And since it's going down, our a term has to be negative to indicate a downward slope. Okay. Now, our vertex has to be exactly halfway between these two. And I realize my graph is sloppy, but that is at 2, which means my h and k, my vertex, has to be a 0, comma, positive 2. I can tell by looking at it, or I can count it out. No need for remembering a half a dozen different formulas to find the 3 key pieces. Sketch the 2 you have, and you can visibly look at your graph and see what your answer is that you're looking for. All right. So this is just going to go nice and easy. All right. There's a quick sketch of my parabola without even knowing what anything else is, just using those 2. Now that I know my vertex, I have h and k, I have 2 of my 3 unknowns. I still have to find a. And fortunately, since I already sketched this out, I can tell that my c is 2. Here's where we're going to use that extra little piece right here. A equals 1 over 4c. All right, that is a constant term. It is a modifying term for your parabolas. It tells you how thin or wide your graph will be. All right, so we plug our c in. That's 1 over 4 times 2, telling me a is 1 over 8. All right, and I'm going to substitute that into standard form. So y minus 2 equals negative 1 over 8. Remember, it's negative because it opens down. Okay. X minus 0 squared, which, of course, is going to simplify to negative 1/8 x squared. And that's my equation. Very, very simple. And it doesn't matter which of the 3 terms they gave you. If they gave you the focus and the vertex, or the directrix and the vertex, you could easily find your missing piece, sketch out your graph, and count your C on the graph. Nice and easy. And then just plug it in to get your standard form. It's very, very straightforward. Sketching will save you a lot of time. Now, before we move on, I'll talk about one last step. All right, and that's how to identify a parabola by looking at it. Okay. In the last section of the conic sections chapter, you will have a page of random equations written in generic standard form. Okay. And you have to be able to determine what the shape is, identify its key features, and then sketch it. Which means you're going to have to complete the square on it. But which standard form you're going to use for circles, parabolas, ellipses, or hyperbola depends entirely on what you have. Okay? And you can tell a parabola very, very easily. It is the easiest one to identify. Because in a parabola, only one variable is squared. In this case, it's x squared. Since it's x squared and y is not, I know right away it has to be a vertical parabola, which means I'm going to be using this equation. So I'm going to complete the square right into that. So first things first, I'm going to move my y and my constant to the other side to get x by itself. And I know some of you out there are going, but wait, we're solving for y. Why are we moving the y instead of the x? And the answer to that is, if this was negative, that would give us an extra step. Right? We would have to cancel that leading coefficient out and divide everything by -1, which is not a big deal. That's true. However, your students are more likely to make a mistake every time they have to change the sign. All right? Signs are always a problem. So anything that you can do to avoid adding an extra step that involves introducing an extra sign change to your problem, the more likely your students are going to be successful. All right? So if this had been negative, I would have added it to the other side. But since it's not, we're just going to reverse our standard form. Now we're going to complete the square on this. So take that 4 and divide it by 2, square that and get 4 again, and we add to both sides, giving us x plus 2 squared equals -8y plus 8. And note that we have a coefficient here in front of our y, but in standard form, all right, it's just y. That is not a problem, because I can see that -8 is a common factor. So we rewrite this with a common factor of -8, y minus 1. And we're going to divide that -8 out from both sides, and that's actually going to become our a, leaving us with y minus 1 over here, and -1 over 8 as a coefficient, x plus 2 squared. So we have our h and k, -2 and +1, and we have our a of -1 over 8, telling us this graph is going to open downward. And we could easily find our focus and directrix by setting our a equal to 1 over 4c and solving for c. And then we can count up and down on our graph to figure out where our focus and directrix are and quickly sketch that out. Right? And that is pretty much everything you actually need to know about parabolas. The book goes into some detail about why it's structured the way it is and the distances between the focus and the directrix, none of which is actually relevant. The section looks intimidating. This is pretty much everything you will ever need to know about a parabola.